So, brief summary for the video. The area that you worked out of the trapezium was 5,488. The sum to 50 terms was 5,600. That's a difference of 112, which just happens to be half of 224, which was the thing that we were summing up over and over and over again 50 times, and then dividing by 2. Okay, so my point here, the connection here, is that the area that we sort of worked out underneath the in the trapezium, specifically the area that was bound by the straight line, the endpoints, and the x-axis, the area is related to this idea of a series, of a sum. Isn't that kind of cool? Because if area is related to sum, then if we had a different sequence, if you could imagine, one that was, or a different graph, how about I say that? If I have a different graph that looks like this, say for example, if I can work out the endpoints, I can then work out the area underneath that, and that will give me a sum that I can use for a different circumstance. Then the other cool thing is that there is a branch of mathematics called integration, which is if you've done advanced or extended maths in year 10, you're probably across calculus, differential calculus, when we find the derivatives of things. Integration is the opposite of that. It's when we go backwards. The integration ends up being the area under the curve. So you don't have to understand what I'm about to do, right? This is just an aside, but I'm making it because, in our maths course, it's great to link things between different topics. That's why I'm doing linear modeling and arithmetic sequences and series at the same time. In this case, the link is if I have that equation, which was y equals, what was it, 4x plus 14? If I work out the integral, if I work out the antiderivative of that, and again, if you haven't done derivatives at all because you didn't do Maths Extended last year, this doesn't even have to slightly make sense. Don't worry about it. So if I work out the antiderivative of it, and just for the sake of this, I'm just going to call it, I'll just use a bit of language here, integral of y. Don't worry about what the language is. I would get 2x squared plus 14x, okay? 2x squared plus 14x. Now, again, for those who remember their derivative work, if you work backwards from this line to this line, you'll see that works. The derivative of 2x squared is 4x, the derivative of 14x is 14. If I look at that and I substitute in, say, 50, because of 1 unit across, don't worry about y, 50 into this, see what we get. We get 2x squared plus 14x. So we have 2 multiplied by 50 squared plus 14 times 50. That's equal to 2 times 2,500 plus 14 times 50, which is, it's got to be 700, does it? So I've stuffed up a little bit here somewhere. So it's 5,700. I probably should have used 49 instead of 50, sorry. But you can sort of see the number there. I know I haven't got it quite right, and that's because I'm kind of making it up as I go along here, and it's not quite working. But that 5,700 is kind of really close to this 5,600, right? The reason why I'm not getting it exactly right is because the modeling is not quite right for the situation. But you can see that the integral, the antiderivative of the equation gives me the area underneath the curve. I should have done 49 times. If I'd done 49 times, then I would have got exactly 5,488. Isn't that amazing that you can take an equation, apply a mathematical rule to it called integration to get a new equation, and that equation defines the area under the curve or the area under the line. And if I have something like this, which is just like a parabola, right, an upside down parabola, then I can then work with the integral, and the integral will tell me what this area is in here. So there's a lot of interconnection here. And then one step further is if I know the area under the curve, then I can link that to a series of events as well, or a series as well. Obviously not an arithmetic series, because that's not arithmetic, but you can link it to some sort of sum, is my point. So it's all interconnected. Okay, so that was really just an aside. You don't have to understand anything that I said there. If the only thing you take away from that is maths is cool because things connect to other things all the time, that's it. The rest of it we learn as we go along. You learn derivatives, you learn integration, you learn how to work out the area under the curve exactly. You do that over the next 2 years. But all of these connections in maths are important. Let's get back to the actual fundamentals. When you're summing up an arithmetic sequence, there are two formulas that you can use. This is summary from yesterday. I don't know if we did formal notes or not, but I'll put a formal heading in there if you want to take formal notes. Excuse my wobbly writing and stuff. It's probably a little bit worse than usual because I don't have my pencil. So we use Sn like this to describe the series to n terms is equal to u sub 1 plus u sub 2 plus ... up to u sub n. That's what a series is. Arithmetic means that u1, u2, u3 form an arithmetic sequence. Arithmetic series means we're adding up those terms in the sequence. We've got two forms of the formula. Sn equals n over 2 outside of first term plus last term. Or Sn is equal to n over 2 outside of 2u sub 1 plus n minus 1d. And yesterday we talked about, kind of feel like my writing's a bit better without the pencil, bigger at least. We talked about why that second form works. So I'm not going to go through that again. And don't forget those braces, the curly brackets, they're just visually different from the round brackets, that's all. They're not special in any way in this instance. Okay, I thought I might just start with a couple of simple examples and then give you some practice time and then maybe come back and do some more tricky ones. Okay, so we'll just go for example 1. So if I had something like 1 plus 5 plus 9 plus ... plus, now I have to think of the last number. That'll do, I suppose. 41, I suppose, that'll do. I think that's right. Then the sum to n terms would be, if you've got the first and last term, use that first form. If you don't have the first and last term, then use the second form. So the sum to n is equal to, oh, I don't know what n is, do I? So I'd have to work it out. So I would go u sub n is equal to 41, which is equal to 1 plus n minus 1 multiplied by d, which is 4. Solve that one. 40 is equal to n minus 1 multiplied by 4. Don't expand it. It's easier to divide by 4. 10 is equal to n minus 1. So n is equal to 11. Is that okay? Then we can go S, the sum to 11 terms, is equal to 11 over 2 outside of the first term plus the last term. which is equal to 11 over 2 multiplied by 42. Now, I just want to put this bit in blue here so you can see you don't have to do this, but I'm putting it in blue because I find that some students who are weak in their fractions don't get this next bit. A whole number can be written as a fraction by putting it over 1. And then I can use cancelling down to say 2 goes into 42 21 times. See what I did there? So 2 goes into itself once and goes into 42 21 times. So just remember, whole numbers can be treated like that. So we've basically got 11 times 21, which is going to be what? 210 would be 10 times 11. So it'd be 200, 10 times 21, so it'd be 231. That could be a calculator operation if you couldn't do that in your head. I'll take a moment for questions. So an easy question would be something like sum 11 terms of 1 plus 5 plus 9 plus ... plus 41. So in other words, you're told there are 11 terms, you're told the first term, you're told the last term, and so you just basically just have to put it in. This is harder because you have to work out that n was equal to 11 before you put it in, so that makes it a more difficult problem. And then you've got a problem like this as well, which I might flick onto the next screen to keep it together. Does anyone need me to wait before? No, cool. And then you've got this. So, again, I'm making it as I go along. For the sequence 10, 8, 6, 2, ... Yeah. Find the sum or series of the first 10 terms. Okay, so you're given the sequence, you're told n effectively, which is 10, and you need to find the sum. And so you set it up. You know what the sum needs. It needs the first and the last term. You could technically go and work out the 10th term and then go from there. But you don't really need to when you've got that second form. You can basically say, well, for the second form, I need to know what the first term is, which is 10. I need to know what the common difference is, -2. Don't forget to keep the negative with it because it's a descending sequence. So therefore, the sum to 10 turns, yep. Have I 10, 8? Yeah, sorry, my bad. It's not very arithmetic otherwise, is it? Sum to 10 turns. Wanted to do 11 terms, but I will. Is equal to 10 on 2. If you want to have confidence with the formula, you might want to, while you're practicing, write the formula each time. Every time you write the formula down, it will give you more brain. It'll connect in your brain a bit better. But otherwise, you should at least just do a straight substitute in. So again, just to remind you, I'll go back for a second. We're using this form of the sequence here. So I'm replacing 10 for n. I'll be replacing 10 for U1, just happens to be the same thing. I'll be replacing -2 for D. So we've got 10 over 2 outside of, 2U1, good. I thought I might have not given you the right formula there. 2 multiplied by U1, which is also 10, plus 10 minus 1, 9, multiplied by the difference, -2. Okay, simplify as best you can in whichever way makes sense. In this case, because I've got 10 over 2 is equal to 5, I'd go straight for that. So 5 And we've got 2 times 10 is 20. 9 times negative 2 is negative 18. So I've got 20 minus 18, which is minus 2. The sum to 10 terms, if I've got it right, is negative 10. Am I making sense there? Do you have any questions? So this is pretty much just given the information, plug in the information to solve. Eve. Thank you. Yes. I told you I'm having a bad day today, didn't I? I mean, I do make mistakes, but I've been making so many today, it's awful. So that would be depressing. 5 times 2, which equals 10. Thanks, Eve. Good pick up. So Iris and Eve have my saviour statuses for today's lesson. Anyone got any questions about that now? It's correct. Okay. I'll stop the video, but you're about to do some worksheet work, just FYI.